Hey, Thomas. Nice to see you again.
Hi, Fabian. Great to be here.
Really appreciate you making time for this. Shall we kick us off with a quick introduction from your side?
Yeah, absolutely. I'm Thomas. I'm, let's say, a seasoned automotive guy, so to say. Just give you a brief rundown of my life. So I studied electrical engineering, did a PhD in computer science. Actually, I started a PhD on AI, and it failed. So I had to stop and change because I started it exactly in the year when, in hindsight, the second AI winter was declared. It was supposed to be with an expert system on a Lisp machine, so this very old-fashioned AI stuff. Since then, I got hooked to AI, and so therefore I'm pretty happy to be here. So after my time at the university, I wanted to become a full professor. Then I found out that, then you're a professor and you do it till the end of your life. And this sounded a bit boring. So then I went for 6 months to Silicon Valley, worked at a company called Synopsys, which was pretty cool. And then decided, let's go to industry for a year or two. So, which led to 25 years at Bosch at the end, where I spent the rest of my professional life in different areas, from microelectronics, many years in driver systems, chassis system, product management, fully autonomous driving at Bosch, which was a pretty cool thing. Headed a whole business unit on infotainment, or this software beasts, which are one of the biggest headaches of the automotive industry, to make that flawless and with a good user experience. So I was really heading that business unit, €1 billion revenue, so quite a decent size. Did some restructuring there, done a lot. Then I went to the headquarters, supported the automotive board in doing automotive strategy, automotive system engineering. And the last 6.5 years, I was heading Bosch Corporate Research, actually, which is a very decent organization. And there are only few companies who still afford themselves a centralized R&D center like IBM or AT&T Bell Labs in former times. And it's a big organization, 1,600 people spread across the globe, headquartered in close to Stuttgart. And this was a lot of fun. And in all areas, so ranging from electrification, automated driving, healthcare, sustainability, manufacturing, and lots of software and AI and many other topics. And also industrializing AI solutions. And I think we'll come back to that later. So I used the term I was. So since end of last year, I'm out. So I reached the age limit at Bosch after 2 extensions. And now I'm out in the wild, out of the corporate industry and supporting startups, doing innovation consulting, things like that, which is a lot of fun.
And podcasts.
And podcasts.
No, thank you so much, Thomas. It's a fascinating overview, really inspiring career. And let's kick us off with the sort of wider GenAI journey of Bosch. As I understand, you've been recently heading up their research division, which is organizationally separate from lots of the other functions at Bosch. How did you approach the topic of GenAI organizationally? What did the sort of general journey look like before we talk about some of the more specific use cases, etc.?
Yeah, absolutely. So GenAI is just a small part of AI. So everybody's talking about GenAI, obviously, but AI is much bigger than that. And a couple of years ago, out of corporate research, there was a study, and it turned out that this will be the next big thing. And this was around 2016. So in AI terms, a century ago, so to say, which was well received from the board and from our former CEO, Volkmar Denner. There was a decision to create a dedicated AI team at Bosch, which at that time was called the Bosch Center for Artificial Intelligence, which was founded in 2017 and was ramped up in parallel to the corporate research, just focusing on AI. After 2 years, we had about 350 people exclusively working on AI stuff. And this laid really the foundation of everything. There was like a basic research part, doing papers in ICML and NeuroIPS, a service consulting part, and an enabling part. So really a training organization. And this is, for me, really a decisive step in the whole thing to enable an organization with basic competencies to do AI. And looking back, I think this was one of the best decisions the board took, and this was well spent money, so to say. And today, we have trained over 30,000 people at Bosch, from web-based trainings to really expert trainings, which last for a year or so with in-depth training and knowledge. And this is the foundation for also all the GenAI activities we are doing now. And should I talk a bit about what we are doing in GenAI?
Just one question there, because I'm curious, and there have been lots of sort of comments about it in previous conversations on here around, especially at incumbent organizations like the OEMs, also the tier ones and probably tier twos. Lots of the decisions are driven by the senior executives, which requires them to understand some of these topics a little bit more deeply. What was your impression from an experience with bringing these very senior leaders of Bosch closer to the topic of GenAI?
The interesting thing is Bosch is a super engineering and even research-driven company. And I think it was really a lucky situation that Volk Madena was the CEO. He's like a theoretic physicist, and he was really a guy absolutely interested in details of new technologies. And he really took himself time. And after that, we had the CTO, Michael Bolle, and they really delved into that topic and got some intricate knowledge. We even gave lectures to them to really educate them. So there was a significant share of time they spent for this topic. And this is different to many other companies where like the very top level managers are a bit away from technology. And this is something which really makes Bosch different from other companies. And one of the reasons I started at Bosch. So they really got it. At that time, 2016, 17, it was not yet clear what really will happen. Well, we had like the deep neural nets, image net, and then this kind of superhuman computer vision algorithms. Nobody was able to foresee what's happening with large language models today. But it laid a great foundation for what we are doing. And if I say we, so I still talk about Bosch, although I'm out for a month now.
Yeah, only recently. No, thank you. That's super interesting. Let's pivot and talk a little bit about use cases, GenAI use cases at Bosch.
Yeah, so what we do, we separate really two application areas. One is really efficiency, so speeding up software development, speeding up engineering. And the other part is product differentiation. So we have many products as a tier one supplier to the automotive industry. But as you know, we are also a conglomerate. So we are doing also ovens, dishwashers, gardening tools, measuring tools. And there's, in the meantime, quite a lot of AI in those appliances also. So these are the two areas. And obviously for GenAI in the closer sense, the application is pretty clear. It's mostly in engineering, like supporting the software development process. A lot of image generation. So we do driver assistance, automated driving. And we all know that getting the data for training is really crucial, especially the corner cases is something you don't get and you won't get. You don't want to have them like children jumping in front of a car. This is something you don't want to have in reality. Yeah, GenAI, image generation, and even movie generation in the meantime helps quite a lot to really train cars in that regard. So these are like two application areas. We also use that in manufacturing for manufacturing efficiency. And there we are somehow victim to the high quality standards. So Bosch is very known for high quality, which means if we produce parts, we are talking about faults in the ppm range, parts per million. So like one part out of a million is defective. And this is a nightmare for AI training because you want also some bad parts to train on, not 1 million good ones and one bad. This is not a good training sample. So you have to create artificial pictures of bad parts. And there the challenges, so like you have cracks or solderings, which went well. And you have to create pictures of defects which are close to reality, not just some weird colors or whatever. It really has to reflect and mimic real defects, real physical defects. And this is something we did in our research quite a lot, very successfully. So you can really create pictures of like coating which didn't work well, or some soldering which didn't work out, or whatever. And with that, you can train classical AI. So you use GenAI to train classical AI. And then you have like optical inspection, which you can use to really get a quality control, which is much better than any human can do. So these are a couple of examples. And we are also using that for in our appliances. And I would broaden it a bit, not only talk about GenAI, but also about foundational models, which mean like these models which are trained with the whole knowledge of the internet. And this is not only language, but also like pictures, like Clip, which is a model, one of the earlier model, where you also have like pictures, and you don't have to train pictures anymore. You can just ask questions or classify pictures based on textual descriptions. And this was something which we put into a Bosch oven, which I found a very interesting example. So there's a Bosch oven, an intelligent one, which has a camera, which helps you to detect what kind of food is in. And for example, if you cook a pizza, when it's ready. And the guys at BSH, the Bosch Siemens Hausgeräte, the household appliances, they bake hundreds and hundreds of frozen pizzas just to get the samples to classify whether pizza is still frozen or good or overcooked or whatever. And the classification results were not that good. And then we came in with one of those foundational models, which were much better. The only problem is it ran on an NVIDIA GPU, which is usually nothing which you have in an oven. Because the GPUs would be more expensive than the rest of the oven. So then this was an exciting project at Kropf Research to distill this model to size which was digestible with the computer which is in the oven, which is more like on the Arduino capability than on the Raspberry Pi capability. Just a very lightweight computer. So just to give you a couple of examples. So really ranging from automated driving to detecting pizzas.
Now, fascinating. I've already seen one of my favorite DIY home tools is this wall wire pipe detector thing before you drill holes into your wall. And apparently there's a new version of that as well that has some enhanced AI capabilities. So may have to upgrade that soon.
This would have been my next example. So thanks for giving me this kind of... So this is exactly what we are doing. And it's like giving you like a picture of what's happening behind your drywall, for example. And you can really classify whether you have like a pipe or some whatever electricity line, but also wood, which sometimes you want to drill a hole into the wood because you want to put a picture on the wall, in the drywall. If you have like a static house, I don't know the English word, then you're even looking for some more stable things. And the interesting thing there is we use a wall scanner and just change the software to an AI-enabled version. So without changing the hardware. And this is even cooler. Just with some kind of over-the-air update, you can put in new software and get the latest and greatest. So that's really cool.
Fascinating. Moving a little bit back to the engineering and manufacturing use cases that you mentioned, how did you approach the discovery and prioritization of these use cases? From my experience, there's usually almost an infinite number of possible problems that you could solve. Some of them sort of on the surface level probably seem sort of suitable for a type of GenAI solution. But what specifically did your process look like?
Yeah, so this is a very good question. So we put that in different buckets. So there's one bucket which we didn't touch at all, which is like marketing, sales, creating movies, automated translation, chatbots. This is where we also use like commercial tools. So this is a no-brainer because there's a very clear defined problem. So you have like, take a household appliance or take a wall scanner. We sell that to, I don't know, 50 countries. So you need 50 manuals in 50 languages, which was a manual translation act. This we automate in the meantime. So this is like this commercial off-the-shelf thing. And then in the automotive domain, there are two parts. One is everything about driver assistance. and automated driving. This is AI at its best. So this division at Bosch is really, I would say, in the automotive part, 2/3 of everything around AI is in that area. Like this image generation, like perception, localization, trajectory planning. So without AI, this is not imaginable anymore. And then we have, so this is like the quick wins. And then we have many engineering problems which are harder. And there we really look at where things which are, let's say, with a high repetitiveness and with a high manual labor, like application of stability control systems, where you have to really apply the software and the parameters to every car, even different motors, variants of a car, because the center of gravity is different and whatever, which is a lot of optimizing control algorithms. And there we also apply AI algorithms to automate it to a certain extent. And the other really big part is manufacturing. Bosch is really a manufacturing powerhouse. We do have more than 300 manufacturing sites across the globe, especially quality control and really looking at defects, at anomalies in the manufacturing. This is a very huge area. And this is one of the first starting points. So we have a solution which is called manufacturing analytics, which is in the meantime applied to more than 2,500 manufacturing lines. So this is working with this data collection and analysis already in place. And it came out of corporate research.
Just on that last point, how did you deliver these use cases? I could imagine that there is usually a combination of having functional expertise, working with the departments, whether it's in engineering, manufacturing, or any other area, and then specific teams there. And then you from the corporate research team, you bring in some of this AI, GenAI capability. So what specifically did the collaboration look like? And how did you, I guess, deliver these use cases from a sort of conceptual idea to proof of concept to a sort of full-blown scaled product?
So I would say we always have like a triangle of people. So we have the division, so the, let's say, receiving end of the whole thing. And then we have like the AI guys and the domain experts in corporate research. So pure AI is nothing. Perhaps large language models, which is pure AI, is something. And this is one of the reasons why they are so successful. But usually you need domain knowledge, either in manufacturing, like how is soldering done, how is coding done, how is drilling done, and what are like quality attributes. So you need like, or designing. We also use AI for generative AI for optimizing and designing e-machines. So completely new designs for an electric motor, which is 200 years old. And everybody thinks it's done. So we have everything. And that's just not true. With GenAI, you find new stuff. So you have like the e-machine domain expert from corporate research, you have the AI guy, and you have like the division on electrified mobility. And these are working together. And the optimization, just sticking with the last example, the optimization goal is pretty easy. Come up with an electric machine which is much cheaper than the ones today, ideally without rare earths and with a higher performance. This would be cool. And we are working on that.
And on that collaboration, of course, not revealing any confidential or sensitive information, but just reflecting on it, what did you think went well? What do you think could have been improved in between the sort of three areas, AI research and the respective department?
Yeah, so I think the first thing is that you speak a common language. And this was a big challenge at the beginning before we did all this training of those many people and all the managers. So all the managers got a basic training at least to get some kind of a basic understanding. And before that, if some researcher came to a vision, talked about reinforcement learning and optimization functions, whatever, it was like, whoa, what's going on here? So speaking a common language is absolutely important. And really have a joint understanding what problem you want to solve. And this sometimes is like a trap for researchers because they come from technology. They have a cool new algorithm and they want to apply it. So it's the classical a solution in search of a problem kind of thing. And this is something we changed over the last couple of years quite significantly, really coming from a problem to be solved and then looking for the best method. Still, it's not easy to be honest, because there's some reluctancy and there's some usual things which you probably have in your former podcast already tackled. It's like you have silos. You have organizational silos and you have data silos. And for AI, you need data. And still, even having 2,500 manufacturing lines plugged into data pipelines, it's not a solved problem. There's a legacy IT over decades with different formats, different data, different responsibilities. And this is really a tedious, long game to be solved. But unavoidable, so you have to go through. Also with, let's say, I would say large language models and foundation models, you don't have to curate your data anymore as precisely as it was necessary before, which is a really big help. So this is data silos and missing in the infrastructure. I think that the biggest obstacle are the humans. It's really cultural resistance, and this is harder than many people think. You don't have to underestimate that. So it's at the end, it's pretty easy. You have two things. So you have like the experts, and there you have like the old expert who has 20 years for some sensors in signal processing. He knows all the encrypted DSP algorithms to optimize, to get the most out of a raw signal from a sensor, whatever sensor it is. And now somebody comes around the corner and says, we don't need that anymore. We just train. Give me some data, some measurements, a couple of 100,000 measurements. I train the AI, and I'm much better than you with your handcrafted DSP algorithms. That people are not excited about that, I think it's pretty obvious. And this invalidation of established knowledge. This is, I think, a big topic people have to talk about and solve it. There are some experts who are really open for the latest and greatest and the newest, and they are cool, but they're the other one who doing the same stuff for 10 years or 20 years even. And there you have a challenge to be overcome. And the others are some managers, and this is also, I think, a well-known phenomenon. Too often, managers define themselves by the number of people they have and the budget they have. So it's like the king, the more people you have, the bigger the crown is, the more horses you have ever. Huh? And which is wrong. Managers should be judged by the outcome, by the impact they're making. And if you're doing more impact with 5 people than others with 200, manager with 5 is obviously the better one. And if you optimize, if you automate stuff with AI, you need not so much budget anymore, and you need fewer people. And even assuming that those people, like baby boomers like me, are retiring, and it's not really a hard problem, and you don't get new people anyway because they're not so much in the talent pipeline anymore. Those managers don't like that because they had like 200 people, and now they could do the same stuff with 50 people. So it's really some unspoken cultural issues which really makes it hard. And therefore, I think what's really important is that you have management commitment from the top, from the very, very top of an organization. And we do have that at Bosch, be it the CEO, now Stefan Hartung, or we have like a chief digital officer, Tanja Rückert, who's pushing especially the GenAI topic very, very hard, in a very charming and embracing way, but the topic is totally clear. And if you don't have that, so this is like a prerequisite, a necessary precondition to be successful. It's not sufficient, but it's necessary. So if from the top people are not believing in that technology, you can stop immediately.
Super interesting that you also emphasize this. I've heard this in so many and seen this in so many conversations, this disincentive of almost sort of reducing your own traditional measures of power in terms of budget and line management responsibility. Moving on to sort of a slightly different area, Bosch, of course, is one of the established tier 1 suppliers, working with probably all of the incumbent OEMs and new entrants in the automotive industry. Traditionally, I know I'm really sort of oversimplifying this here. From my understanding, there has been this sort of somewhat top-down relationship between the OEM and the tier 1 supplier, where the OEM is generally sort of quite determining, using massive RFP, request for proposal documents, requirements, descriptions of what they want from their suppliers. And what I've heard and seen in some of the sort of previous conversations and conferences, sort of anecdotal evidence of that this might be changing due to GenAI associated with things like they don't really always know what they want. There are use cases that tier ones see that the OEMs might not be aware of. From your experience, how is GenAI changing this relationship between the OEMs and the tier ones? And then is there also sort of a new breed of the hyperscalers like Microsoft, AWS, etc., that move closer into this landscape?
Absolutely. And to be honest, it doesn't start or didn't start with AI. It started much earlier. It started with complex software systems. And this is what I experienced when I was responsible for infotainment system, where we really created super complex software systems. And we are talking about like 30, 50 million lines of code. Also really monsters. And with a good part of open source software. So we at that time, we were based on GenAI Linux, so really like an open source software stack, which was very cool. And this was exactly then my experience. So I knew from before, like OEM asking for a radar sensor. Then you get like this requirement specification, and then you have like your platform, and you have to make matching between what you have in your offerings and what the OEM wants, and somehow come to a joint understanding, and then in a very more traditional waterfall kind of development method to develop what the OEM wants. With infotainment, that didn't work anymore, because you get I got specifications, and we implemented it to the sentence what they specified. And like after a year, the highly ranked managers of car manufacturers, they sat in the car, they played around with like the first release, and they said, "What's that for BS? Unusable! You didn't do what we want!" And they really shouted at us. And like after 30 minutes, we just showed it's exactly what you specified. Oh yeah, but this doesn't work. No, obviously it doesn't work, because it's highly interactive, complex user interface. And those projects where the car manufacturers stuck to this waterfall model, they really went not so well. And the most successful project were like, yeah, we have a specification, but it's like a starting point for discussion, and let's work together in a trustful relationship. We car manufacturer, trust you, Bosch, that you know what you're doing. Let's do it iteratively, create something very quickly, and then we sit in the car together. We decide what works, what doesn't work, and we refine it and go into this kind of iterative development process, which requires a lot of trust, which is very hard for the procurement of the car manufacturer, because it's totally unclear what it will cost. And you have to find like a balance that it's like a win-win situation, and the tier one does not, let's say, breaks out money because new requests, and on the other hand, the car manufacturers has to confine himself to a reasonable set of changes, which not go beyond everything. But if you come to that point, and if the managers have like a personal relationship, and they trust each other and say, okay, we've got to solve the problem, then it really works. I think AI projects are just the next level of that, because what I experience also, like playing around with AI myself, creating code automatically. So we talked about that previously. I do some kind of a audio classification on a Raspberry Pi for rooster cries, because I'm living on the rural side. And this was like a fun project. I want to know how much code I can create with ChatGPT O3 Mini High. The answer is 95%. And I was really blown away. But what I found out, it's a highly interactive process. So the AI is coming up with something, it's working, but it's not really what you want. And then you get into this kind of interactive mode. And I think these AI-driven projects will be the very same, or are already the very same. You have a triangle, the car manufacturer, the tier one, and AI. And the three have to work together somehow, iteratively, and refining the solutions. Is the automotive industry prepared for that? Not everywhere. And there, my experience is that other countries, like in China, they're much more open for this working style, with this kind of good enough mentality. Let's do it quickly and fix it afterward kind of thing. totally different from this European 100% quality style, and let's test it for years before we release it. This doesn't go well with AI, I think.
Oh, fascinating. Super interesting. Just building on that last point and zooming out a little bit as we're sort of coming to the close of this conversation. Are there any particular technological areas that you're excited about, that you believe sort of in the realm of AI, Gen AI, are disrupting some of the areas you've spoken about around engineering, manufacturing, maybe especially autonomous driving, etc.?
Yeah, absolutely. And this is also goes hand in hand with the question, what do companies do on their own themselves, and what they just buy from the hyperscalers? And I think I would not give away Bosch manufacturing data to any hyperscaler, to be honest, because this is precious data. And like our sensor data, and this is like this domain knowledge. Keep with ourselves and work with that. Other things like this code generation we talked about. Hey, C++, Python code generation. This is nothing one tier one supplier should do. This is like common engineering practice around the globe. And there are companies who can do that much better. The thing I'm most excited, which is a very recent one, I think I'm excited about two things. One is open source models, and like the recent publishing of DeepSeek's model as open source really changed something also on the stock markets, because for many applications, these open source models are more than enough to solve your problems, more than enough. And some of them really have also licenses which allow you to use those models in your application and refine them and distill them and whatever. So this is one thing I'm very excited. And I think the open source models, they just have time delay of, I would say, 3 to 6 months. In the meantime, they're directly behind the closed shop models. So this is something which excites me very much. And the other thing which excites me even more as a researcher and somebody who is really interested in innovation and has worked on that is the deep research things which you can now find from OpenAI and also Perplexity. So we can try that out for free with Perplexity, really giving hard problems or really like a standard task I got when I was president of corporate research is like some managers, some divisions, or even a board member asking us, hey, I heard about this new technology for whatever, electrical machines, for batteries, for sustainability, for carbon capture. Can you assess this technology, whether it's just a hype or some new things happening? And usually you would put 1 or 2 researchers for 4 weeks on that topic, and they would write a report or make a PowerPoint presentation and answer that problem. You can do that now in 10 minutes. Really, you ask the very same question and you have like a large language model based machine with chain of thought, creating a research plan systematically looking at publications and company websites, whatever, digesting the information, preparing reports, assessing the report, refining it, assessing it again, and then presenting it to you. I've never seen that before. And the quality of information is really mind-blowing. And the last thing, which is my private favorite is the Google Notebook LM, where you can create out of the most boring documentations and publications a podcast, which you can listen to in your car in a quality which is really super exciting.
Actually, I haven't checked that out. Need to have a look later. Final question from my side actually links very nicely to the last corporate point you mentioned. You mentioned there around experimenting. You mentioned that you're now talking to one of the senior executives in charge of the organization's GenAI strategy and implementation work, whether that's at a tier 1, at an OEM, or a similar organization. What would be your top 3 recommendations to make sure they unlock the most value from GenAI in a safe, reliable, sustainable way in their respective organizations?
So my first recommendation would be try it out yourself. Seeing is believing. Try it out. Use ChatGPT or whatever you're interested in and get some kind of a first-hand experience. And especially these chat systems, whether it's the one from Google, from OpenAI, from Meta, or Mistral or DeepSeek, whatever, gives you an idea what's possible in the meantime. And this you need, I think you need that at the foundation for your decision making, because otherwise you think it's all like hype. It isn't. It's I think one of the biggest invention in human history. Really. The second thing is, don't do AI for the sake of AI, just because it's cool to do some AI stuff. No, this is like the technology-driven thing or the marketing-driven thing. Look at the problems, the hardest problems you have to solve, and most of them are solvable, or at least massively, how to say that? You can massively enhance the efficiency by employing AI. And the third thing is avoid a big mistake. The big mistake is just to look how people perform, execute processes, and substitute part of these processes by an AI automation. This leads to nothing. This leads to like 10, 20% efficiency gain. You have to rethink whole processes, whole value chains, and come up with totally different solutions. So not just incrementally, step by step, substituting small mosaic pieces in your enterprise with the AI, but really rethinking your value proposition, your products. And this is the hardest part, because people are used to the style of working they did, and senior managers got like, I wouldn't say brainwashed, but meticulously trained in a certain style of working and optimized that for many, many years or decades even. And now you have to change it. And that's the hardest part. Yeah. So this are my 3 recommendations.
No, thank you so much, Thomas. That's been super insightful. Really appreciate you making time for this today.
Yeah, absolutely. So I'm open for discussion. If whoever wants to contact me should do it. I recently created a website. It should go online within hours. So thomaskropf.com. And whoever wants to reach out to me, just punch in thomaskropf.com. And
no, brilliant. Thanks. I can also, I'm pretty sure, link this in the description of the episode.
Yeah. And I love to discuss this stuff, give presentations, talk to people. And I also learn quite a lot working with startups, how they approach things differently. And sometimes they have a much easier job because they don't have all the legacy of the big corporates, which is good. So a lot of knowledge in big companies, but it also makes change slow. And this is the challenge. But with the right mindset and the right people, I think you can overcome it. And it's not only efficiency, it's really the whole way we work, and you have to make it a strategic priority. And trust, you need a lot of trust, because you have to try out stuff and trust your experts. And especially young people, they can give you a lot of good advice. So there's this kind of reverse mentoring where young engineers from diverse backgrounds mentor senior managers. We also had that at Bosch. Highly recommend it, because then you get new insights.
No, thank you so much again, Thomas. I'm going to make sure to link your website below.
Sure.